This lesson's on the commutative property of addition. The word commutative comes from the word commute, which means to go back and forth. For example, if you were going back and forth between your home and school every day. The word property doesn't mean something that you own or land, but it means a rule, in this case a basic math rule for addition. So the commutative property of addition is a rule that says when adding numbers, for example 5 plus 4, you can change the order of the numbers without changing your answer, in this case 9. So we could say that 5 plus 4 is equal to 4 plus 5 because of the commutative property of addition. Usually it is stated as A plus B equals B plus A. What do the letters A and B mean in a commutative property? The letters A and B can represent different numbers. For example, in our example, A equals 5 and B is equal to 4. Let's say if our job is to add the numbers. Some people would prefer to add the 5 first, or in other words, A first plus B. We know that 5 plus 4, when we add it together, is going to be equal to 9. Other people would prefer to add the 4 first, or in other words, B first plus A. The question is, which is the correct way to add those numbers? The answer is both are okay because of the commutative property. Both ways have the exact same amount of objects. It's just the order has changed. So we could say that 4 plus 5 is also equal to 9, and therefore 5 plus 4 is equal to 4 plus 5. Or in other words, A plus B is equal to B plus A. And that's what we mean by the commutative property of addition. Here are some things to look for when solving problems using the commutative property of addition. First is make sure it's addition. By that we mean on both the left and the right side of the equations. Both must be addition. Next, we must have the same numbers on the left and the right. For example, on the left we have 5 and we have 5 on the right, so that's good. We have 4 on the left and we need to have 4 on the right. Last, we need to make sure that the order of the numbers must be different. For example, on the left, 5 plus 4, we can't just slide that over and have it be the commutative property of addition. The 5 and 4 would have to be switched to make that the commutative property of addition. We have 3 problems and then we'll be done. Problem 1. Which equation shows the use of the commutative property of addition? A. 27 plus 9 equals 9 divided by 27. Does that look right? We have addition to the left, but there's division, so we cannot use that. That is not the commutative property. B. 27 plus 9 equals 27 plus 9. Does that look right to you? We have addition on the left and on the right, but notice that 27 plus 9 on the right, the order is exactly the same as it is on the left. So this is also not the commutative property. C. 27 plus 9 equals 9 plus 25. We have addition on both sides, but notice that the 25 on the right side doesn't match the 27 on the left, so that can also not be the commutative property of addition. D. 27 plus 9 is equal to 9 plus 27. We have addition left and right. That's good. We have 27 on the left and 27 on the right, and we have 9 on the left and 9 on the right. And notice that the order of the numbers is changed. So that's why D is the correct answer for the commutative property of addition. Problem 2. Solve, write your answer in the box. 629 plus 835 equals blank plus 629. Both sides have addition, so that's good so far for the commutative property. On the left, we have 629, and on the right, 629 as well. And I notice that the position has changed, so far so good. On the left is 835, but on the right, we don't have anything. So what should we do? Remember, the commutative property of addition is A plus B equals B plus A. Because they have to be equal, B on the left equals 835, which means that we're going to use B also on the right. So our answer is 835 for problem 2. Problem 3. Which of the following is not an example of the commutative property of addition? The key word is not. A. Z plus D equals D plus Z. That meets all 3 of the criteria for the commutative property, and we cannot use that because we are looking for something that is not. B. 8 plus 3 equals 3 plus 8. I notice it's squeezed together, but sometimes you'll see problems like that. But that is also the commutative property, and therefore we can't use it for this question. C. 6 plus 12 equals 18. Is that the commutative property? No. So this is the correct answer for this problem. And we can see that D is also the commutative property, which means we can't use it for this answer. Thank you very much. If you made it this far, great job. I hope this was helpful today, and we will see you on the next one.